Welcome back. The topic of this interactive video lesson is on understanding fractions. Objectives. In this lesson, you will learn how to represent a fraction using a variety of models, rename a fraction by expanding or reducing it, and order fractions. Fractions can be a part of a length, a part of a whole, or a part of a group. Let's look at the length model. The length model is like using a ruler or tape measure. A linear scale is divided into parts of equal length, and an object is measured with a scale. This scale is divided into 8 equal parts, that is, eighths. The length of the bar is 3/8. This scale is divided into 4 equal parts, that's fourths. The length of this bar is 3/4. Expanding fractions. Notice that we can represent 1 as a fraction. We have 8/8 in the top and 4/4 in the bottom. So 1 can be 8/8. 1 can be 4/4. A fraction equals 1 whenever the numerator, the top number, is equal to the denominator, the bottom number. 1 can also equal 2 halves. It can also be 3/3. 1 multiplied by any number equals that number. For example, 1 times 3 equals 3, or 1 times 9 equals 9. The same is true when we multiply a fraction by a fraction that equals 1. 3/4 times 2 halves. Well, we multiply in the numerator and denominator, and we get 6/8. So 3/4 is equivalent to 6/8. We can also take 3/4 and multiply it by 3/3. Multiplying on the top, we get 9, and on the bottom, we get 12. So 3/4 is equal to 9/12. We are renaming the fraction by expanding it. 3/4, 6/8, and 9/12 are equivalent fractions. If we look at a number line, we can see that they're equivalent. They represent the same length. Part of a whole model. The part of a whole model is represented by a shape. The area of the shape defines the whole. The shape is divided into parts of equal area. The fraction is the area of the shaded part as it relates to the whole area of the shape. So in the top, we have 3/4. In the middle, we have 2/5. And on the bottom, we have 5/6. Notice in the top, it's divided into 4 equal parts, and 3 of them are shaded. In the middle, it's divided into 5 equal parts, and 2 of them are shaded. And in the bottom, it's divided into 6 equal parts, and 5 of them are shaded. Part of a group model. When a fraction is represented as a part of a group, there are several similar shapes or objects. Some of the objects in the group are shaded, while others are not. We interpret each model this way. Notice in the top one, we have 6/9. We have 9 objects in total, and 6 of them are shaded. In the middle one, we have 4/8. That is 8 objects in total, and 4 of them are shaded. And in the bottom one, we have 1/4. 4 objects in total, and 1 shaded. Notice the total number of objects is the denominator, and how many are shaded is the numerator. Simplifying or reducing. We can divide a fraction by a form of 1 to simplify or reduce it. Create a stack of similar shapes with equal numbers in each. So in this case, we have 3 stacks. The shapes in each stack should be the same color. Notice 2 of the stacks are blue and 1 of the stacks is white. Now divide the fraction by a form of 1 to find the simplified or reduced fraction. If we divide it by 3/3, which is just 1, well, 6 divided by 3 is 2 and 9 divided by 3 is 3. So 6/9 is equivalent to 2/3. Now here, we have 2 stacks. One of them is blue and one of them is white. Each stack contains 4. So we'll divide by 4/4, which is just 1. And we get 1 in the numerator and 2 in the denominator. Notice 4/8 is equivalent to 1/2. Expanding. Since 1/4 is already in simplest form, we can find an equivalent fraction by expanding it. Multiply the fraction by a form of 1 to expand it to an equivalent fraction. So here, I'll multiply by 2/2, essentially doubling it. So we get 2 in the numerator and 8 in the denominator. Notice we now have 8 squares and 2 of them are shaded blue. Remember, divide to reduce and multiply to expand. Placing fractions on a number line. We can use fraction factory bars with a number line to improve our understanding of fraction. Use the chart on the right to place the following fractions on the number line. 1/2. Well, that would go right here. 2/2. Well, that would go right here. Notice 2/2 is the same as 1. How about 1/3? That's here. 2/3 is here. And 3/3 is here. 1/4 is here. 2/4 is here. Notice that's equivalent to 1/2. 3/4 is here. And 4/4 is here. It's 1. And now we have 1/5 here. 2/5 here. 3/5 here. 4/5 here. And 5/5 or 1 here. Use the number line to compare 2/3 and 3/5. Well, 2/3 is here and 3/5 is here. So 2/3 is greater than 3/5. How about 1/3 and 2/5? Well, 1/3 is here and 2/5 is right here. So 1/3 is less than 2/5. 3/4 and 6/8. 3/4 is here. 3/4 is here. And 6/8 is here. They're the same. So 3/4 equals 6/8. Now how about 4/12 and 1/3? 4/12 is right here. And 1/3 is equivalent. So 4/12 equals 1/3. What about 5/6 and 4/5? Well, 5/6 is right here, and 4/5 is right here. So 5/6 is greater than 4/5. How about 1/6 and 1/5? 1/6 is here. 1/5 is here. So 1/6 is less than 1/5. How about 2/10 and 2/8? 2/10 is right here, and 2/8 is right here. So 2/10 is less than 2/8. How about 1/2 and 6/12? 1/2 is here, and 6/12 is also here. They're equivalent. Now how about 7/8 and 10/12? Well, 7/8 is right here, and 10/12 is right here. So 7/8 is greater than 10/12. Comparing fractions with sections of a whole. Use a pie chart model to compare two fractions, like 2/3 and 3/5. Create two pie charts. Divide the first into 3 equal sectors and the second into 5 equal sectors, like so. Shade 2/3 of the first pie chart. Shade 3/5 of the second pie chart, like so. Compare the sizes of the two shaded areas. And we can see that 2/3 is greater than 3/5. How about 1/3 and 2/5? Well, let's create two pie charts. We'll divide the first into 3 equal sectors and the second into 5 equal sectors. We'll shade 1/3 of the first pie chart and 2/5 of the second pie chart. Now we'll compare. Overlaying them, we see that 1/3 is less than 2/5. How about 3/4 and 6/8? Create two pie charts, divide the first into 4 equal sectors and the second into 8 equal sectors, like so. Shade 3/4 of the first pie chart and shade 6/8 of the second pie chart. Now compare the sizes of the two shaded areas. Overlaying them, we see they're equivalent, so 3/4 equals 6/8. Use a fraction bar model to compare the fractions. 4/12 and 1/3. Draw two identical bars, divide the first bar into 12 equal sections and the second bar into 3 equal sections. Shade 4/12 of the first bar. Shade 1/3 of the second. When you look closely, you can see that 4/12 equals 1/3. How can you compare the fractions without using a model? We can rename each fraction so that they have a common denominator. What is the lowest common multiple of 12 and 3? List the multiples of 12 and 3, then find the lowest common multiple. That would be 12. Multiply 1/3 by a form of 1 that results in a denominator of 12. We'll multiply by 4/4. This is a form of 1 because 4/4 equals 1. We have the same number on the numerator and denominator. Notice we multiplied by 4/4 because that will give us a 12 in the denominator. And if the denominators have the same number, then we can just look at the numerator and compare the numerator. So now our bar is divided into 12 equal parts, and 4 of those are shaded, so this is 4/12. Notice 4/12 equals 4/12. Pause the lesson and compare these fractions, 5/6 and 4/5, using both methods. Resume the lesson to check your work. Well, let's draw out our bars. In the first one, we'll divide it into 6 equal parts. In the bottom one, we'll divide it into 5 equal parts. On the top, we'll shade in 5, that's 5/6. And in the bottom, we'll shade in 4, that's 4/5. Now we can see that 5/6 is greater than 4/5. But now let's look at the least common multiple of the denominators, 6 and 5. Listing out the multiples of 6 and the multiples of 5, we scroll down until we see that 30 is the least common multiple of both. So we need to multiply by a form of 1 to get 30 as the denominator. So we'll multiply 5/5 in the top. Notice that would give us a denominator of 30. When we multiply, we get 25/30. Notice we have divided our bar into 30 equal parts and 25 of them are shaded. Now for 4/5. Note we want 30 in the denominator. So what can we multiply 5 by to get to 30? Well, that's 6. So our form of 1 will be 6/6. So now we have 24/30. Notice our bar is divided up into 30 parts and 24 of those are shaded. Now we can easily compare. 25/30 is greater than 24/30. Again, if the denominators are the same number, we can just look at the numerators and see which one's greater. Let's do this again. Pause the lesson and compare these fractions using both methods. Resume the lesson to check your work. 1/6 and 1/5. Well, let's draw our model. In the top one, we shade in 1 of the 6 parts. In the bottom one, we shade in 1 of the 5 parts. And we see that 1/6 is less than 1/5. Now let's use the least common multiple method. Finding the least common multiple between 6 and 5, well, we did that on the last slide, but we can see that it's 30. So what will we multiply 6 by to get to 30? Well, that will be 5. So we'll multiply this by 5/5. And we get 5/30. Notice our bar has been divided up into 30 parts and 5 of them are shaded. Now for 1/5, we look at the denominator, 5. What do we need to multiply that by to get to 30? Well, that will be 6. So we will multiply this fraction by 6/6 as its form of 1. That is dividing the bar up into 30 parts. And 6 of them are shaded. So that's 6/30. Now when comparing these, we can see that the numerator, 5, is less than the numerator 6. So 5/30 is less than 6/30. One more time. Pause the lesson and compare these fractions. Resume the lesson to check your work. 7/8 and 10/12. Well, drawing out our bars, we have 8 equal parts in the first and 12 equal parts in the second. We'll shade in 7 on the top and 10 on the bottom. So now we have 7/8 and 10/12. And now we have that 7/8 is greater than 10/12. Now let's try the least common multiple method. 8 and 12. Let's list out the multiples of each. And we see that 24 is the least common multiple. So now we need to multiply by a form of 1 to get 24 in the denominator. So let's take 7/8. What will we multiply the denominator 8 by to get to 24? Well, that will be 3. So our form of 1 will be 3/3. So now we have 21/24. Notice our fraction bar model is now divided into 24 equal parts and 21 are shaded. Now for 10/12. Let's look at the denominator, 12. What do we need to multiply 12 by to get to 24? Well, that will be 2. So our 1 will be 2/2. And we get 20/24. Now we see the numerator of the first, 21, is greater than the numerator of the second, 20. So 21/24 is greater than 20/24. Use a group of squares to compare. 2/8 and 18/24. Represent 2/8 by drawing a group of 8 squares and shade in 2/8 of the squares, like so. Now represent 18/24 by drawing a group of 24 squares and shade in 18/24 of the squares. Notice that we can reduce 2/8 and 18/24 to fourths. Divide 2/8 by a fraction that equals 1 so that the denominator is 4. Well, 8 divided by what is 4? Well, that will be 2. So our 1 in this case will be 2 halves. So we'll divide by 2 halves. And we see this is 1/4. Divide 18/24 by a fraction that equals 1 so that the denominator is 4. So 24 divided by what equals 4? Well, that would be 6. So our form of 1 in this case will be 6/6, and that's what we'll divide by. And we see we get 3/4. Now we can compare these, 1/4 and 3/4. Notice the denominators are the same, so we look at the numerators. 1 is less than 3, so 1/4 must be less than 3/4. Pause the lesson and compare these fractions. Resume the lesson to check your work. 4/8 and 6/12. Using the grouping method, we have a group of 8 and 4 of them are shaded. And we have a group of 12 and 6 of them are shaded. Notice we can simplify this group into 1/2. 4/8 divided by 4/4 is 1/2. And now for this one. Notice we can group this one into 2 groups as well, and we get 1/2 as well. So 6/12 divided by 6/6 is 1/2. So comparing, we see they're equivalent. So 4/8 equals 6/12. Notice in the first grouping, when we combine them together, we had 4 in each group. And that's why with 4/8 we divided by 4/4, because there were 4 in each group when we combined. In the second grouping, there were 6 in each group when we combined, and that's why we divided by 6/6. Again, pause the lesson and compare these fractions. Resume the lesson to check your work. 10/15 and 4/12. For 10/15, we have 15 squares and 10 of them are shaded. For 4/12, we have 12 squares and 4 of them are shaded. Notice we can group. In the first one, we group into 3 groups. Stacking them together, notice we have 5 in each group. So we can take 10/15 and divide it by 5/5. And we get 2/3. In the second, we have 3 groups. And we have 4 in each group. So 4/12 divided by 4/4 is 1/3. Now we compare. Since the denominators are the same, notice 2 is greater than 1, so 2/3 is greater than 1/3. Therefore, 10/15 is greater than 4/12. Alright, now we're ready to do more challenging examples.